Dear students, welcome back. So last time we have seen the methods of preparation of alkyl halides. Okay, first method we saw was from alcohols. The second method I have also mentioned, that is from hydrocarbons. Methods of preparation. And that is from hydrocarbons. From hydrocarbons. Now, alkyl halides, we are talking about alkyl halides. Okay, alkyl halides are prepared from saturated as well as unsaturated hydrocarbons. So if you take from saturated hydrocarbons, that is alkanes, right? Alkanes. Actually, this method is also done in the 11th standard, the chemical properties or the preparation of alkyl halide from hydrocarbons. Alright? This method for hydrocarbons, and that too saturated hydrocarbons, is not very feasible, or it is not in use nowadays, or it is not used. Why? I will be telling you. Okay. Now if you take any alkane, saturated hydrocarbon, okay, from alkanes, if you take an alkane CH3 CH2 H, okay, alkane. Which alkane is this? This is ethane. Plus halogenation of alkanes gives you the corresponding alkyl halides, plus Cl2 in presence of UV light or diffused sunlight. Diffused sunlight. What will it give you? It will give you the alkyl chloride, that is CH3 CH2 Cl. Barabar? Ethane chlorination, it is undergoing chlorination, but specific conditions, UV light, diffuse sunlight, giving you the alkyl chloride. Secondly, we take the same ethane, CH3 CH2 H plus bromination. Alright, bromination. But now the condition is AlBr3. Okay, and then what will you get? You will get CH3 CH3 Br. Alkyl bromide is obtained. Similarly, iodination, CH3 CH2 H plus I2. So these are what? Halogenation reactions. Reaction of an alkane with halogens X2, Cl2, Br2, I2. That reaction is called as halogenation. I2, but now you will have to use HiO3 or you will have to use HGO. Okay, and what will you get now? CH3 CH2 I. Of course, here the byproducts HCl plus HBr plus HI. Now this reaction or this method of preparation is not generally used. Why? Because it has got some limitations. What are the limitations? Now if you take this chlorination, you have to use the specific UV light and diffuse sunlight. This will take place in this condition only, this reaction. The other drawback is that the reaction will not stop at this stage. Okay, what would happen is, in the next step, one more hydrogen of the parent alkyl halide will be replaced for another you can say atom of Cl, correct? And you will get 2 hydrogen being replaced for 2 chloro groups. Similarly, the next step would be that the 3 hydrogen atoms would be replaced for 3 chloro atoms. And the fourth step would be that the 4 hydrogen atoms attached to the carbon atom will be replaced for 4 chloro atoms. Now the reaction is a continuous process. It does not stop somewhere. And finally, you will obtain a mixture of alkyl halides. Okay, and the separation of the mixtures and obtaining it in a single step is a very long process, and it is not at all you can say economical, as well as it cannot be used, because it will be getting mixture of alkyl halides. Okay, why? Because it is a you can say continuous reaction. Same thing with this bromination. Again, 1 atom will be substituted, and then you will get 2 bromo atoms attached to the carbon atom. Okay, 3, and then finally 4. So this is also a continuous bromination. It will not stop at the first stage, but it will continue, and you will get a mixture of alkyl halides, and then the separation becomes very difficult. Alright. In case of iodination, you cannot just represent it like this. What could happen is you will get this alkyl iodide in the first step, that is ethyl iodide, and HI. But what will happen? This HI will again react back with this alkyl halide, and you will get back the products. So what is such a type of reaction called as? It is called as a reversible reaction. So again it will not stop. This will react with this, give you back the products, the reactants. The reactants will react, give you back the products. Okay, so it has to stop somewhere, and in order to stop that, we have to use HiO3 and HGO or HGO, correct? Mercurous oxide. Did you follow it? So here these are the drawbacks, that this is a reversible, so it is not feasible, because then the reaction will not stop at a certain stage, it will not be limited. And same way in this case, of course, fluorination reactions are very violent reactions, and usually you do not carry out fluorination, okay, in order to prepare alkyl halides. Did you get it? So this is from saturated hydrocarbons. The second from unsaturated hydrocarbons, that is from alkenes. You have done this in the alkene chapter of 11th, C double bond C. Correct? Now you have seen the 2 cases. Okay, now I will rub this out, sorry. From alkenes. What are these? These are hydrocarbons, but unsaturated hydrocarbons. C double bond C. Now I'll take a simple, you can say, example. CH2 double bond CH2 plus. How are alkyl halides obtained from alkenes? That is by addition of hydrogen halide. Hydrogen halide. Now these hydrogen halides may be HCl, they may be HBr, they may be HI. Okay, HF usually not to be used. Okay, now if I carry it out with HCl, what's going to be the product? CH3. So hydrogen will bond here and chlorine will bond to this carbon atom. Correct? CH3, CH2, Cl. So what are you getting? You are getting an ethyl chloride from ethene. Now the same thing, CH2 CH double bond CH2 plus we take the other alkyl halide, other alkyl hydrogen halide, that is HBr. Okay, now what is happening in this case? All right, HBr is an unsymmetrical reagent, H plus and Br minus. Similarly, this is an unsymmetrical alkene. If you recall, जर तुम्हाला आठवत असेल तर 11वीत आपण अल्किन्स जेव्हा चॅप्टर लर्न केलं तेव्हा इथे हे आपण फॉलो केलेले आहे. वी हॅव सीन. ऑलराइट, नाउ सी दिस. According to Markovnikov's rule, the negative part of the reagent will attach to that carbon having less number of hydrogen atom attached, and then the hydrogen to the other carbon atom. Remember that addition always takes place across the double bond. So what are you going to get here? You're going to get CH2, CH, Br, correct? And single bond. If I write it like this, it will be better. CHBr and single bond CH3. What is happening in this case? The double bond is being replaced by the single bond. And how does addition take place? Addition takes place across the double bond. Got it? How does addition take place? It takes place across the double bond. Now, since this is an unsymmetrical reagent and the addition we are going to study for an unsymmetrical alkene, this question arises. And so, this addition is according to Markovnikov's. KOFFS किंवा मार्कोनिकॉव्स पण म्हटलं जातं आता. ठीक आहे, ॲडिशन. दुसरा काय आहे बघा. Sorry, this should have been CH3 here. Okay. Now CH3, CH, double bond CH2. Okay, plus HBr. But if this addition is carried out in presence of a peroxide exactly opposite to that of Markovnikov's rule, the addition takes place, and therefore it is also called as anti-Markovnikov's. Anti-Markovnikov's rule. Correct? And then what will you get? Exactly opposite. Negative part of the reagent will add to that carbon carrying more number of hydrogen atoms. And the hydrogen will go to this carbon atom. And what are the compounds obtained? Product obtained? CH3, CH2, CH2Br. Correct? So how will you name this compound? 1, 2. 2 bromo propane. Correct? What about this compound? 1, 2, 3. So this is 1 bromo propane. तर एक्झाम मध्ये लक्षात ठेवायचं आहे. काय लक्षात ठेवायचं आहे की जर तुम्हाला अल्किन्स दिलेला आहे त्यामधनं आपल्याला अल्किल हलाइड ऑब्टेन करायचा आहे, स्पेशली द ॲडिशन ऑफ HBr. ठीक आहे, दोन पद्धतीने ते ॲडिशन होतं. एक तर मार्कोनिकॉव्स रूल. मार्कोनिकॉव्स रूल आपण केव्हा फॉलो करायचा? जेव्हा तुम्हाला ॲरोवर पेरॉक्साइड दिलेलं नाही. समजलं? जर इथे पेरॉक्साइड दिला आणि तुम्ही हे लिहिलं प्रोडक्ट, दॅट इज रॉंग. गॉट इट? सो HBr असेल तर आपण ते अँटी मार्को, पण पेरॉक्साइड असेल तर आपण अँटी मार्कोनिकॉव्स रूल फॉलो करायचा आहे. ह्या रूलला आपण पेरॉक्साइड इफेक्ट पण म्हणतो. पेरॉक्साईड इफेक्ट. आणि डिटेल्स तुम्ही 11वीच्या अल्किन चॅप्टर मध्ये केलेलं आहे. ऑलराईट, ओके. हे झालं. आणि आय एम गोइंग टू पेज नंबर 213. तुमचं टेक्स्टबुक आहे तुमच्याजवळ 213. पुढे जाऊयात आपण. ठीक आहे. Halogen exchange. What are we learning? We are learning the methods of preparation of alkyl halides. Next method is the halogen exchange. Halogen exchange. All right. Halogen exchange. Correct. Now in this case, the alkyl chlorides or alkyl iodides are prepared conveniently. This is the best method for the preparation of alkyl iodides. Okay, conveniently prepared alkyl iodide prepare करायचं आपल्याला. Okay, by treating the alkyl chloride or bromides with sodium iodide in methanol or acetone. Very simple. When you take an alkyl chloride, correct, and you treat it with sodium iodide, correct, in presence of acetone, the what will be obtained now? Only there is exchange of places. All right. And what will you obtain? Ri plus NaCl. So simply there is an exchange of the halogens. Simple exchange of halogen atoms. Did you get it? And this is the most economical, most convenient method for the preparation of alkyl iodide. Correct? Now this method has got a, or this reaction has got a special name, and it is called as, see here, Finkelstein reaction. Finkelstein reaction. Alright? alkyl iodide प्रिपेअर करायचं आहे तुम्हाला. कशातनं? alkyl chloride किंवा alkyl bromide मधनं. काय करणार? alkyl chloride घ्यायचं आहे, सोडियम आयोडाइड घ्यायचं आहे, आणि इन प्रेझन्स ऑफ acetone. Simple exchange of the iodides and the chloride takes place, and you get an alkyl iodide. This reaction is called as the Finkelstein reaction. बघा, 1 मार्काचं MCQ, बरोबर ना? तिथे तुम्हाला ऑप्शन्स असतील. So this is it. Got this? Now, same way, when you want to obtain alkyl fluorides, again alkyl fluorides are obtained करायचं असेल तर you will take an alkyl chloride plus silver fluoride, correct, and you will get RF plus AgCl. All right. This reaction, what is happening? F is taking the place. Now see, usually you do not get fluorides, but this method is giving you the preparation of an alkyl fluoride. And this method for the preparation of alkyl fluorides, okay, alkyl fluorides is known as Swartz. See here, SWARTZ, Swartz reaction. Got my point? ही झाली तुमची halogen exchange method. All right? Right? So here we have seen the next method of preparation. All right? Now we have one more method for the preparation of aryl chlorides and bromides. तुम्ही इथे बेन्झीन मध्ये केलेलं आहे. ठीक आहे? समजली नेक्स्ट मेथड? ओके. Next method that I am going to deal with is the electrophilic substitution method. Aryl chlorides and bromides, aryl closed chain, can be prepared by direct halogenation of benzene and its derivatives through electrophilic substitution. Correct? It may be carried out in the dark at ordinary room temperature also. Correct? In presence of Lewis acids such as Fe or FeCl3. Okay? Now see, I'll give you a simple example. Benzene CH3 attached, so this is toluene, correct, plus Br2 in presence of the Lewis acid, that is Fe, and in dark, what are you going to get? What are you going to get? You are going to get electrophilic substitution plus you get a mixture. This is toluene plus bromine in presence of Fe, and in dark condition you will get a mixture of ortho-bromo. And what is this? Para-bromo. Ortho-bromo toluene. I hope my pronunciation is okay. And this is para-bromo toluene. Okay? So this is the next method for usually preparing aryl. Aryl means aromatic chlorides or iodides or bromides, whatever. Alright? Yes. Now, Sandemeier's reaction also is given here, which is the next reaction, page number 214 we are following. And that method is giving, is also one method of preparation of alkyl halides. But it is given in details in the chapter that is you replace nitrogen of the diazonium salt. So nitrogen and its compound, when you study that chapter, this other method, that is by Sandy. You have to remember these named reactions. Sandemeier's reaction. Okay? Sandemeier's reaction काय आहे हे तुम्हाला जेव्हा तुम्ही चॅप्टर 13 करू आपण नायट्रोजन अँड इट्स कंपाऊंड डायझोनियम सॉल्ट मधनं अल्किल हॅलाइड कसं मिळतं तेव्हा आपल्याला दिस इज गोइंग टू बी क्लिअर टू अस. ओके, सो हिअर वी हॅव ब्रश्ड अप विथ द आपण बघितलंय वेगवेगळे प्रकार द मेथड्स ऑफ प्रिपरेशन ऑफ अल्किल हॅलाइड्स.